All right, so from the packet from yesterday, if I have a degree of 1, how many total real zeros do I have? 1, right? Okay, hold on. So if I have 1 total 0 and my degree is 1, what can you tell me about that function? From yesterday. Please tell me. So on the end behavior, it goes in opposite ways. Okay, so it goes in opposite ways, which means that it has to do what? It has to cross the x-axis, right? How many times is it going to cross the x-axis? Once. That means that we have 1 real 0. Do we have any imaginary zeros? How many total zeros? 0. Or how many total zeros? Total. 1 total one, right? And if that 1 is real, that leaves us how many imaginaries? 0. There can't be an imaginary 1 there. Okay? Degree of 2. How many total zeros can I have? 2. Okay, I got to have 2 total zeros. What is the least amount of zeros that I could have? 0. I could have 0 real zeros. It could not cross the x-axis at all. It can be a concave up parabola, and it could be above the x-axis. It could be a concave down parabola, could be below the x-axis. Okay? If I have to have 2 zeros, and none of them are real, how many of them are imaginary then? 2. Gotta have 2. Okay? Can I have 1 real 0? I can, but what did we call that yesterday? Called it a double, right? Okay? So really that 1 counts as 2. Okay? So I really just have, so I can't have 1 because really it's 2. I see it as 1, but really it's 2 because it's a double. Okay? Can I cross the x-axis twice? Yeah, so I could cross twice. If I cross it twice, then how many imaginaries are there? 0. Okay? So there are my options there. If I have a degree of 3, how many zeros do I need to have? Total zeros. Need to have 3 total zeros. Okay? Degree of 3 tells me what? Opposite directions again, right? Okay? Opposite directions means I have to cross at least once. So if I have 3 total zeros, and one of them has to be real, how many imaginaries? 2. Can I have 2 real zeros? But one of them would be one of them would have to be a double, right? So that one counts as 2. So really then there's 3 real zeros. If I have 3 real zeros, means I have 0 imaginary ones, right? Okay. What was the other rule that we said yesterday about imaginaries? They have to come in doubles. Okay. You can't just have a single imaginary root. They come in pairs. Okay. 4 now. If I have a degree of 4, that means I have how many total zeros? 4. Okay? Smallest number of possible zeros there. 0. And if I have 0 total zeros, that means I have how many imaginaries? 4. Okay? can I have one real zero in a quartic function? Can I have one real zero? If I had one real zero, that means I'd have how many imaginary zeros? If I had one real zero, that means I'd have 3 imaginaries, right? And what's wrong with 3 imaginaries? Not in pairs. So I can't have 1. Can I have 2 reals? Yes. If I have 2 reals, how many imaginaries? 2. Can I have 3 real zeros? No, because then I'd have 1 imaginary, right? Okay. Can I have 4 real zeros?
Yes.
Which then means I'd have how many imaginaries? 0. Degree of 5. How many total zeros? 5. Can I have 0 real zeros? No, because then I'd have 5 imaginaries. Can I have 1 real zero? Yes, that means I'd have 4 imaginaries. Can I have 2 real zeros? No, because then that would leave me with 3 imaginaries, right? Can I have 3 real zeros? Yes, that leaves me with 2 imaginaries. Can I have 4 real zeros? No. Can I have 5 real zeros? That leaves me with 0 imaginaries.
So we can't have like odd number imaginary zeros.
You cannot have odd number imaginary zeros. They have to come in pairs. Okay? 6 total zeros. 6. Can I have 0? Which would mean I'd have 6 imaginaries. Can I have 1? 2 means I have 4 imaginaries. 3, 4, which means I have 2 imaginaries. 5, 6, which means I'd have 0 imaginaries. All right, extension time. If I have n for my degree, how many total zeros am I going to have? N, right? Because the degree tells us how many zeros we're going to have. Okay? So if I'm looking at the maximum real zeros, what would the maximum real zeros be if my degree is n? It'd be what? N, right? 6, the maximum was 6. 5, the maximum was 5. 4, the maximum, the biggest one was 4. 3, biggest one was 3. 2, the biggest one was 2. 1 is 1, right? So the biggest is n. Now, what's the pattern then after we get the biggest one? It goes down by 2 every time. Okay? So then the other possibilities, subtract 2. Okay. And then these 2 columns here, reals plus imaginaries, has to be equal to n. Okay? Real plus imaginary has to be equal to n. Now, the last concept that we need to talk about in terms of this is terms. Okay? Talking about turns. Now, when we're talking about a turn, we're not turning like we're not turning like just to the side. We're making a turn. So our function is going from, let me go back here to a fifth degree function. Our function is going from increasing, this is increasing here, and then now it turns and it starts going down, it becomes decreasing. So this right here is a turn. Okay? Then, as your function is decreasing, it suddenly turns and it starts going back up again. That is increasing there, or that's a turn right there because now it's going back to increasing. Here would be another turn because it turns back to decreasing. Here would be another turn, it turns back to increasing. So in a fifth degree function, there are 4 turns possible, right? Here is a fifth degree function. There's a turn there and there's a turn there. That's 2 turns possible. Here's a fifth degree function right here with 0 turns possible. Okay? So what can you tell me about turns? Anything yet? It's what? The biggest number of turns is n minus 1. Okay? So the biggest number of turns is n minus 1. And then the other possibilities are 2 less than that, right? Okay? So let's put that to the test here. A quartic function has a degree of 4, right? So here's a turn, here's a turn, there's a turn. That gives me 3 turns, right? That's my maximum number of turns. So then we do that minus 1. The other possibility would be 1 turn. Okay? So in answer to this one, go back through it. Degree of 1. How many turns can we have? 0 turns. Okay? And a straight line doesn't have any turns. It's either always increasing or it's always decreasing. You don't get any switches there. Degree of 2. Most number of turns. 1. Okay? It goes from increasing to decreasing, or it goes from decreasing to increasing. Degree of 3. Most number of turns. 2. But you could also have how many turns? 0. Yep, you could also have 0 there. But the most is 2. Degree of 4. Most number of turns. 3. But you could also have just 1 turn. Degree of 5. 4. But you could also have 2 and 0. So if we had a degree of n, the most number of turns would be n minus 1. Okay? Today, what we're going to be doing is we're going to be looking at graphs again, but we're going to actually give you graphs to look at, and we're going to have you find minimums and maximums. Those are those turn points. And we're going to have you find if they're relative or if they're absolute and things of that nature. Okay? And that's all going to be on the worksheet packet.